All right, let's talk through the mastering specific heat. If we were to compare the temperature of the metal part of a seatbelt belt buckle versus the plastic part of the buckle after the car had been outside for hours on a hot day, the metal will reach a higher temperature. So, which do you think has a higher specific heat, the metal or the plastic? The answer would be the plastic. It takes more energy to change the temperature of the plastic than it does the metal. That's why the metal got hotter. All right, two beakers are filled with room temperature water. Beaker A contains 100 grams of water. Beaker B contains 200 grams of water. If the same amount of heat is transferred to each beaker, will the final temperature of beaker B be greater than, less than, or equal to the final temperature of beaker A? Explain. The final temperature of this one is going to be less than beaker A because there is a greater mass of water in beaker B. So because there's more water, the thermal energy, if it's the same amount given to both, it's not going to have as great of an effect. It can't, make that much of a difference. Like if I were to try to draw this in a picture form, here's my beaker with 100 grams of water. Here's my beaker with twice as much. If my thermal energy, oops, I wanted to make my T, I'll make my thermal energy units be a T. They're way more spread out in this one. So this one would have more of an impact and change the temperature a greater amount. You've got a sample of oil and a sample of water. Both have the same mass and both have the same initial temperature. You put the sample of oil on one hot plate and the sample of water on another hot plate, and you heat both until they reach a final temperature of 40. Did the water sample gain more than, less than, or the same amount of energy as the oil sample? Well, the water sample must have gained more because water has a higher specific heat than oil. Water has a higher specific heat than oil. So it requires more energy to change an equal amount of oil, the same change in temperature. Sample 1 contains 100 grams of water at 20 degrees Celsius. Sample 2 contains 100 grams of water at 30 degrees Celsius. If equal amounts of energy are applied to each sample, will the temperature change of sample 1 be greater, less than, or equal to the temperature change of sample 2? Well, it'll be equal. Sure, they're starting at different temperatures, but let's say that the amount of energy makes the temperature rise by 5 degrees in sample 1, it'll go up to 25. And in sample 2, the temperature change will be equal. It'll also go up 5 degrees. So they will have different temperatures because sample 2 started off at a higher temperature. The specific heat of aluminum is about double the specific heat of copper. So it's easier to heat up copper than it is aluminum. If you were to place one 20-gram bar of aluminum and one 20-gram bar of copper in a boiling water bath, which metal would increase in temperature faster? Well, the copper would, because it has a lower specific heat. So in other words, it requires less energy to change the temperature of 1 gram by 1 degree Celsius. We learned that 4.2 joules of energy, it takes 4.2 joules of energy to increase the temperature of 1 gram of water by 1 degree Celsius. So how much energy would it take to increase 2 grams by 1 degree Celsius? Well, it would take double. It would take, 8.4 joules. Okay, how much energy does it take to increase 1 gram of water by 2 degrees Celsius? Also 8.4 joules. How much energy does it take to increase 2 grams of water by 2 degrees Celsius? So that's basically doing 4.2 times 2 times 2. So that would be what? 16.8 joules. Finally, it only takes 1.7 joules of energy to increase the temperature of 1 gram of mineral oil by 1 degree Celsius. So how much would it take to increase 2 grams of mineral oil by 2 degrees Celsius? So we're going to multiply here. What is 1.7 times 4? 1.7 times 4, it would take 6.8 joules. Use your answer from letter D to justify the results from experiment 3 on page 5. So let's go back and look at our results from experiment 3. It was easier to heat up the oil. The temperature change was more dramatic because oil has a lower specific heat. So it's easier to heat it up. So it takes less energy to heat an equal amount of oil as it does water, because oil has a lower specific heat. So hopefully that's getting you a little more comfortable with using and practicing the concept of specific heat.